is your second part video for 2-5, completing the square. And we're going to kick off here with a word problem. So we have here, Libby plans to create a rectangular pasturing enclosure. She has 340 meters of fencing available for the enclosure's perimeter and wants to have an area of 6,000 meters. And we want to know what dimensions Libby should use. So you have a couple things you have to think about here. The fact that perimeter is twice the length plus twice the width for a rectangle, and area, which is actually what we're going to be solving, is length times width. Now we do have some numbers that we're going to put in here, and I'm going to start first with perimeter, because area is what we are trying to make the most of, but we can't do this question using two separate variables. So we actually need to do some substitution and make it so that we are putting the width in terms of the length or the length in terms of the width. And so I'm going to use the perimeter equation to do that. I know that 340 is my perimeter. And for this type of question, I'm actually going to put everything in terms of length. So I'm going to take my perimeter equation and I'm going to solve for the W, because then all I'll be left with is my L variable. So I'm going to subtract the 2L, so I have 340 minus 2L is equal to 2W, and then I'm going to divide everything by 2, so I get 170 minus L is W. So anywhere there is a W, I can substitute in 170 minus L. It's always helpful whenever you do these, and this is a common question whenever you're dealing with something that's rectangular, because it's going to have different length and width number values. Anytime I have a W now, I can put in 170 minus L, and that's what I'm going to do over here. So my area is 6,000. L is going to stay L, but W, I'm going to change to 170 minus L. If I distribute this, I get 6,000 is equal to 170L minus L squared. I notice that I have a quadratic. So this is something that we can actually either factor or we can do the quadratic formula on. I want to keep my quadratic term positive, so I'm actually going to move everything over to the left-hand side. So I have L squared minus 170L plus 6,000 is equal to 0. You could try to go through and factor this. I know that the factors of 6,000 are probably not something that is going to come super easy, and that's where completing the square might be your better bet, because you don't have to worry about doing your factors, you just have to follow the process. So in order to do the process, I do want to move that 6,000 over. And then I have to do my b over 2 squared. So it's negative 170 divided by 2 squared. Well, negative 170 divided by 2, and then when you square it, you're actually going to get 7,225. This is going to be equal to 85, so this is 85 squared. And then we're going to add that to both sides. Factor the left-hand side. Notice this is going to be an L minus, and the square root of 7,225, as I said, was 85. And then this is going to be 1225. So I'm going to extend my page here so I have more space. I forgot my square. Take square root of both sides. Plus or minus, square root of 1,225 is 35. And then you would add the 85. So my length is going to be 85 plus or minus 35. That means that my length could be 120. Or my length could be 50. And if you recall up here, if we look at the original question, I would take I do 170 minus the length to get the width. So it doesn't really matter which of these numbers that we would use for the length because the other number is automatically going to be the width. So the dimensions, if we go back to the original question, what they're asking for, what dimension should Libby use? So the dimensions, in this case, that are going to give us 6,000 square feet of area and a perimeter of 340 is going to be 120, let's check the units here, meters, 120 meters by 50 meters. You don't have to specify which one is the length and which one is the width because all it asks for are the dimensions, and this would be the dimensions. So this is a way to use the completing the square on a word problem. This way we didn't have to go through and guess about what the factors would be. If you had picked 120 and 50, both of them would have to be negative, then you might have been able to bypass all of this and jump right to getting your solution, but it might have taken you a while to come up with those factors. Okay, now we're moving on a bit. We're going to look at vertex form. Vertex form is very closely related to completing the square. You actually use the same b/2 squared process because in vertex form, remember you have that parenthesis, that x minus h squared. So we actually use that the same way that we would. I'm going to show you one. This one is a little more difficult than the one I'm going to show you next. So just be aware of that whenever we're going through. So to write in vertex form, the first step is the same. You're going to take whatever's in your C position and move it to the other side. Only in this case, there's nothing to combine because there's already a y there and I have to keep the y in my problem. You also need to make the x squared have a coefficient of 1. We can't divide to get rid of that, so I'm actually going to factor out, and that is going to come into play whenever we add our b/2 squared term to both sides. So I'm going to factor a -2 out of both of those terms. That's going to leave me with x squared minus 5x. Notice here, if I were to redistribute the -2, I would get what I underlined in blue up in the original question. So now we do our b/2 squared term. Your b is going to be the new term that you have inside the parentheses, not the original b term that was in the problem. So this is -5/2 squared. That is going to be a decimal. It's up to you guys whether you want to use the decimal or the fraction. I'm actually going to go the fraction route. So this will not reduce, but when I square top and bottom. So that's going to be 25/4. I'm going to leave some space here because we factored this -2 out, you have to be careful when you're adding to the left. But I am still going to add it to the right-hand side. Now, you see where I added it inside the parentheses because this is now a perfect square trinomial. 25/4, even though it's a fraction, it is a perfect square because I can take the square root of it. It's 5/2. It doesn't give me a repeating decimal. But everything that's inside that set of parentheses is multiplied by -2. So to keep my two equations balanced, I can't add just 25/4 to the left-hand side because I actually added -2 times 25/4. So anytime you have a number on the outside that you factored out, you have to multiply that by your b value whenever you add to the other side of your equation. So I'm adding -2 times 25/4, not just the 25/4. So -2 times 25/4, the 2 and the 4 are going to reduce, so this is really -25/2. So -1 minus 25/2 is going to be -27/2, which as a decimal is going to be 13.5. And then this is going to factor into x minus 5/2, quantity squared. And then the only thing left to do then is take your term here that's after the y and you put it back on the other side. This is actually your k value here. So it says graph it. I'm just going to do a quick graph here because I don't have a whole lot of space. So we have 2.5, my vertex is actually going to be as decimal, 2.5, 13.5. So let's call that 15, 1, 2, 3. So I would be up about like this. And y-intercept is 1. So we would be coming up something like that. And it says, what is the maximum minimum value? This graph does open down because it starts with that negative. So this would be a max. And the max value is the y value of the vertex. So there's my vertex in vertex form. Again, typically, whenever you have a value in that A position, you are going to get some of the decimals that you wouldn't get normally. But the process is very similar to completing the square. You move the C term over, factor out if needed, find your B over 2 squared, add it to the right inside the parentheses if you factored. On the left, if you have this number on the outside, like we have the -2, you have to multiply those whenever you add. Then you want to factor the right-hand side, combine to get your k value, and then move your k value back over. So now we're going to look at one that's a little easier. I'm going to call this example 6. This one we are going to write in vertex form as well, but this is one where you do not have to factor. So you can see how much easier this process goes whenever your a value is equal to 1. It seems like that's a common theme. When a is equal to 1, it's a whole lot easier than if a is anything else. By the way, if a was a -1, you would still have to factor that negative out and multiply by the negative on the left-hand side. So first step, move the 7 over. There's nothing to factor out, so I don't need to put any parentheses. Do my b over 2 squared. B is 6. 6 over 2 is 3. 3 squared is 9. Because I did not factor out, I can just go ahead and add that to both sides of my equation. So this gives me a y plus 2. This factors into x plus 3 squared. Subtract the 2 back over. I have x plus 3 squared minus 2. So your vertex here is -3, -2. And it would be a min of -2. Min because a is positive, so your graph is opening up. When it's opening up, it's going to have a minimum. Okay, so that's vertex form. You saw a harder question and an easier question for that. Again, very closely related to completing the square. That's why it's included in this section. Go back through, watch this video, go back and watch the first part video, and contact me if you have any questions about completing the square or vertex form.